OK, that's actually it for how DNS works. It was 2 main ideas, followed by a lot of somewhat ugly implementation details. Oh, I shouldn't say ugly. It's kind of nice. But anyway, now we can talk about the security of DNS and what attacks are possible. So most of the attacks that we'll talk about in DNS have to do with cache poisoning. This is usually what attackers want to do when they're attacking DNS. Now, you could probably do other things like denial of service by cutting off a DNS response. But the most common thing that people want to do when they are attacking DNS is cache poisoning, which basically means taking a malicious record and returning it to the client. If you return a malicious record, the client will cache that malicious record, and we say that their cache is poisoned. So this is really just a fancy way of saying we want to send them malicious records and trick them into accepting them. Why is cache poisoning useful for an attacker? Why is it dangerous? Well, let's say that I open a web browser and I type in eeks.berkeley.edu. My computer issues a lookup and says, what's the IP address of eeks.berkeley.edu? And let's say an attacker successfully does cache poisoning. It sends back a malicious record that says eeks.berkeley.edu has IP address 6.6.6.6, this very evil IP. So now, if I'm the victim, I don't know any better. I take this IP and domain mapping, I cache it, and now anytime I want to talk to eeks.berkeley.edu, like if I want to send my UC Berkeley password, where am I sending it? I'm sending it to 6.6.6.6. So now the attacker is a man in the middle. Anytime I'm trying to talk to eeks.berkeley.edu, my traffic is going to the attacker instead, where they can read and modify it before possibly forwarding it to its final destination of eeks.berkeley.edu. That's cache poisoning. It's dangerous, and it's what attackers most often do when they're trying to mess with DNS. So who can do cache poisoning? Who do we have to worry about? Let's go through all the different network attackers that could possibly try this attack and make things bad. So one possible risk is a malicious name server. Imagine if somebody hacks into one of those name servers and takes over control of the name server. Well, now, if you ask that name server a question, that name server can lie and give you a malicious answer. So that's bad. We don't want attackers to hack into name servers. That's a risk that we have to worry about. So here, we made a query to the berkeley.edu expert name server, but an attacker hacked into it, and they gave us some bad answer. So this is something we want to avoid.